Okay, so today we're going to go over 4.2, which is the definite integral. So today we looked at, or yesterday we looked at integral problems, meaning finding the area under a curve, which is what an integral does. Today we're going to look at the easier way of doing rectangles. So the definition of a definite integral is that little squiggly integral symbol that I drew for you guys a few times, where a is going to be on the bottom, it's your lower limit, and b is your upper limit. And then you put your function. You always include dx because that says that we're deriving it at x instead of, so if you were going to derive it at y, you'd put dy. But we won't derive things for y, we'll only derive things for x. And that equals the antiderivative from b to a. So f of b minus f of a. Okay. So if I look at example 2, I'm given the integral from 0 to 3 of x cubed minus 6x dx, so derived at x. And if you recall from what we've looked at, the antiderivative of x to the n is x to the n plus 1 divided by n plus 1. So we're going to use that formula for this antiderivative. So if I break it into my three pieces, this is like taking the integral of x cubed dx minus the integral from 0 to 3 of 6x dx. And so if I integrate x cubed, 3 plus 1 gives me 4, so I'd get x to the 4th divided by 4. And I'm going to evaluate that from 3 to 0. And then if I do the same thing for 6x, 1 plus 1 is 2, so I get 6x squared divided by 2. And I'm going to evaluate that from 3 to 0. Okay, so if I plug in 3 to x to the 4th divided by 4, I get 3 to the 4th divided by 4. And then I subtract my lower estimate, so 0 to the 4th divided by 4. Then if I do the same thing for 6x squared divided by 2, I get 6 times 3 squared divided by 2 minus 6 times 0 squared divided by 2. So then if I keep simplifying, 3 to the 4th is 81, so I get 81 divided by 4. 0 to the 4th is 0, so 0 divided by 4 is 0. If I distribute my minus, I get minus 3 squared is 9, and 9 times 6 is 54 divided by 2. And if I distribute my subtraction, I get plus 0 squared is 0, 0 times 6 is 0, 0 divided by 2 is 0. Okay, so then I can ignore my zeros because those mean nothing. So I end up with 81 divided by 4 minus 54 divided by 2. Okay, so I'm going to times this one by 2 to have common denominators. 54 divided by 2 is 108, so 108 over 4. And what's 81 minus 108? Negative 27, is it? Yes, 27? Okay. I don't trust my brain today. So my area under my curve would be negative 27 over 4. So let's do the same thing for example 3, the integral from 2 to 5 of x to the 4th dx. Okay, so the integral of any x to the n is x to the n plus 1 divided by n plus 1. So if I do that for x to the 4th, 4 plus 1 is 5. So I get x to the 5th divided by 5. And I'm going to evaluate that from 5 to 2. So if I plug in my number that I'm evaluating from my upper limit, if I plug in my upper limit 5, I get 5 to the 5th divided by 5. And if I plug in my lower limit, I get 2 to the 5th divided by 5. Does anybody know what 5 to the 5th is? Divided by 5. $625, okay. And what's 2 to the 5th divided by 5? $32 divided by 5? What's 32 divided by 5? 6.4. Okay. And what's 625 minus 6.4? 618.6. So my area under that curve from 5 to 2 would be 618.6. Okay, so far so good. It's easier than drawing rectangles. I agree. Then we're going to look at how to do it on your graphing calculator, because that is even simpler than doing it by hand. So if I want to find the area from 0 to 1 of the square root of 1 minus x squared dx, first thing you're going to do is graph square root of 1 minus x squared dx. Leave off the dx, so just y equals square root of 1 minus x squared. Just put just square root of 1 minus x squared in your graphing calculator. Just that. Yep. Graph this in your graphing calculator. In doing so, you get a graph that looks kind of like that, right? Kind of like a little half circle. No, you don't even have to zoom in. Okay, once you're there, I want you to go to second calc, where it pulls up all the different calculation things you can do. And number 7 is the integral of f of x dx. So that's what you want to select, is number 7. Once you do that, it'll populate your graph back on your screen, and it'll ask you for your lower limit. What's my lower limit?
Negative. What would that be all the way?
For this integral, what's my lower limit? 0. Okay, so when it asks you for your lower limit, you hit 0 and hit enter. Then it will ask you for your upper limit. What's my upper limit? 1. Hit 1, hit enter, and then it will shade underneath the graph, which is kind of hard to see because this is a small graph. And what does it tell you your area is? So the area under your curve is approximately 0.785.
And this is like, this is instead of doing the rectangle.
Mm-hmm.
It's like the rectangle, we just have to put this.
Mm-hmm. Yep, this is the exact area. The rectangles were an approximation. This will give you the exact area. So I'm going for the exact area. Okay, so let's do another one. Let's do x minus 1 from 0 to 3. So graph the graph x minus 1. You should get a straight line going through y equals negative 1 and x equals 1. And then follow the same steps. So second, calc. Go to number 7. Ask you for your lower limit, which is what? 0. And your upper limit, which is 3. And a little shade underneath your graph until 3. And what does it tell us that our area then is? 1.5. Okay, so the last thing we're going to look at is the properties of integration. So the first property, number 1, tells you the integral from a to b of c dx of any constant is just that constant times b minus a. The integral of f of x plus g of x, so if you're adding two functions, you can just break it up into the integral of f of x plus the integral of g of x. Just split up all your different pieces. Let me get just scroll down. If I look at number 3, it tells me the integral of some constant times a function, d of x, is equal to that constant times the integration of that function. So basically you pull your constant out front and you don't evaluate it until the end. And lastly, number 4 tells me that the integral of f of x minus g of x, we can also split up into the integral of f of x minus the integral of g of x. Okay, so if I look at my exam, the last example, I'm given the integral from 0 to 1 of 4 plus 3x squared dx. And I'm asked to rewrite it using the properties and then to solve it. Okay, so the first property I'm going to use is property 2, which tells me I can split this up into two different integrals. So the integral from 0 to 1 of 4 dx plus the integral from 0 to 1 of 3x squared dx. I just split that into two pieces. Then if I look at this first part, the integral from 0 to 1 of 4 dx, that's like property what? What does that kind of look like?
1.
Property 1, right, where this is some constant. So that tells me that I take my constant times my upper limit minus my lower limit. The second thing I'm going to do is I'm going to look at property 3, which tells me that any constant can be pulled out front. So I'm going to have 3 times the integral from 0 to 1 of x squared dx.
X cubed over 3.
Okay, so if I integrate this, I get x cubed over 3, and I'm evaluating it from 1 to 0. I still have the 3 out front, that constant. And if I finish evaluating 4 times 1 minus 0, that just gives me 4. Okay, so if I plug in 1, I get 1 cubed divided by 3. And if I plug in 0, I get 0 cubed divided by 3. Well, what's 1 cubed divided by 3? 1 over 3. Okay, and 0 cubed divided by 3 is 0, so I can just ignore it. So I get 4 plus 3 times 1/3. What's 3 times 1/3? 1, and 4 plus 1 is 5. Okay. So you guys are going to work through page 306, 1 through 6, 1 through 25, and 31 and 32. Shouldn't be super hard. Remember that if it's not easy to integrate them using your integration rules, then to graph it and use your calculator.